In this video, we are going to go over the all-important and very cool idea of describing patterns. Patterns come up in life all over the place, whether it's something like you feel a rumbling in your stomach around lunchtime and you think, you know what, I'm hungry. That's a pattern that happens very frequently, right? Or it could be other patterns that happen within math. Too often we skip over patterns and just go into memorizing steps of what to do. But the patterns that we are going to see, especially in later math concepts, are going to open up a world of awesomeness. Let's dive right into a basic example of how we can describe patterns. So here you're given a table of data, right? Real world information where we are told we have a number of cans of soda, 1 can, 2 can, 3 cans, 4 cans, and then 5 cans of soda. And we're told that we have 35 grams of 35 grams of sugar in 1 can of soda, 70 grams of sugar in 2 cans of soda, and 105 total grams of sugar in 3 cans of soda. We are asked to describe the pattern. So we need to see what's going on there. Now, some people are just going to look at this and say, I get it, I understand what the pattern is. To me, I think it's more important that we look at the relationship between each of the categories. So independently, meaning I'm going to look at the differences of the cans of soda. And what I notice is that the number of cans of soda goes up by 1. So that goes up by 1, right? 1 plus 1 is 2. And between 2 and 3 cans of soda, we go up by 1. 3 and 4 cans of soda, we go up by 1. And 4 and 5 cans of soda, we again go up by 1. So that's nothing extraordinary. I'm going to do the same thing on the right-hand side. I want to look at the difference between how much we go up or down by on the amount of sugar. Well, we start at 35 and go up to 70. If I do 70 minus 35, I will get plus 35. So that's the difference between the two. And then again, from 70 to 105, 105 minus 70 is plus 35. And we're going to assume that that pattern continues, right? So what is the pattern? For every 1 can of soda that we add to the amount that we're tracking, we add an additional 35 grams of sugar. So another way of saying that is there's 35 grams of sugar per or in every can of soda. Very cool. Okay. So then we are asked to use basically that description, which I'm not going to write out. Who wants to watch a video of someone writing out the description I just made? You could rewatch that description if you need to. We're going to use that description to complete the table. We are going up by 35 for every additional can of soda that we add to this table. So if we went up another 1 can, we'd go up another 35 grams of sugar. And so that's 105 plus 35, which is 140 grams of sugar. And then we're going to do that again. We add 1 more can of soda, and we're going to add another 35 grams of sugar, which is 175 grams of sugar. There's a lot of sugar. Now, the question becomes, how many grams of sugar will 9 cans of, I put 9 cans of sugar, oh my word. How many grams of sugar will 9 cans of soda have? There it is. Caught that error. Man, can you imagine cans of sugar? Ooh. Anyway, so how do we figure this out? Well, to go out 9 times, we kind of need to figure out what's really going on pattern-wise here. Let's rewind a little bit. I said that for every 1 can of soda, we get an additional 35 grams of sugar. So we're repeatedly adding 35 grams for each can. Sounds like we're multiplying by 35, right? If I'm repeatedly adding 35, so I have 1 can of soda, 1 times 35 is 35, right? Just noticing that 1 times 35 is 35. And then I have 2 cans of soda, 2 times 35. Well, that's 70, right? 35 added twice gives me 70, and then 35 added 3 times, or 3 times 35 gives me 105. Ooh, and then 35 added 4 times for 35 grams of sugar per can times 4 cans is 140 grams of sugar. And then 5 cans is 5 times 35, which is 175. So if I need 9 cans worth of sugar, so 9 cans of soda, how much sugar is in it? I would have 9 times that I've added 35. And when we do that math out, we get, a little bit of mental math, I believe it's going to be 315 grams of sugar. So if we listen to the descriptions that we give to these patterns, they often lead us to some very neat mathematical patterns. Awesome, awesome stuff.